All right, welcome back. You came back for more. Ha! Okay. In this video, we're going to take what we learned in the previous video about significant figures, and we are going to do some examples. So these are also occasionally affectionately referred to as sig figs. So significant figures are also sig figs. Sig Fig Examples. I guess I could have abbreviated that to EX since I'm abbreviating the other things. Sig Fig Examples. Okay, so what I'm going to do is I'm going to just pitch some kind of off the top of my head, and then you have a PDF linked. We'll pull that. I am going to work under the assumption that you do not have a printer, and I will also not print most things, and will kind of show you how I do it on paper. If you do have a printer, you are invited to print anything you want because it can be really helpful. But and make a packet. we'll just do this as we are. Okay, so you figured out that numbers like that, there's no zeros in that number. Thank goodness. Okay, so if the question is how many sig figs in this number? Okay. A lot of things between quarter A and B, don't overthink it. The number 2,397 has 4 sig figs. Good. This is a comma. I'm just going to erase it just in case it doesn't look like a comma. 2,397. Just count them. 2 is significant, 3 is significant, 9 is significant, 7 is significant. There's 7. There's 7. 1, 2, 3, 4. There are 4 sig figs. Okay. The number 82 has 8 is significant, 2 is significant. There are 2 sig figs. We'll do one more like that. 4,879, 3, 2, 1. I'm not going to write the commas just so it doesn't get confusing. This is just on the paper. Actually, I will write the commas because of that thing. Count the numbers. Significant. These are all significant. That has 7 significant figures. I'm going to start throwing zeros at you. Number 201. There are 3 types of zeros. If you are looking at a zero and trying to figure out if it is a measured place of confidence and therefore significant, this is a middle zero. It is in between 2 significant numbers. 2 is significant, 1 is significant. Because the 0 is in between the 2 and the 1, it is also significant. That has 3 sig figs. Let's just take that and expand on a good idea and take it a little step further. That's enough zeros. Here again, this one looks a little funky because you're like, that's a whole lot of zeros, just one after another. They're all middle zeros. They've got a significant number at the beginning, they've got a significant number at the end. That tool can measure all of those place values. They are all significant. This number has 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures. Because those are all middle zeros. Let's just jot you a note in case those are all middle zeros. Okay, let's do some example beginning zeros. 0.073 has, these are both beginning zeros. Beginning zeros are never significant. The 7 is significant, the 3 is significant, it has 2 sig figs. We'll just do another one like that. This is 73, and all this tells me is that there's nothing else, which is fine, but I don't really care. This has 2 sig figs. Don't overthink it. Some of these things, don't overthink. Middle zeros are always significant. Beginning zeros are never significant. Ending zeros, if you're looking at an ending zero, you're looking for the decimal. Now, I gave you a decimal right here because I want to like highlight that beginning zeros are never significant, even if there's a decimal involved. This just means it's a small number, but you already knew it was a small number. That didn't like tell you anything interesting. Differently, let's take that same 73 and put some zeros over on this side. These zeros are at the end of the number, they're ending zeros, and there's a trailing decimal. In math class, you wouldn't have to write that decimal. You could, like, math doesn't really care. By writing that decimal, you're saying it's worth printing ink or pencil or whatever you're working with. It's worth writing the decimal. Therefore, the meaning is we are confident in those zeros. This is like if you had a measuring tool and the measurement came in exactly on the line. Great, so we wrote the decimal. So therefore, 7 is significant, 3 is significant. Those we knew. These are ending zeros with a trailing decimal. That 0 is significant, and that 0 is significant. This one has 4 significant figures. Both of those decimals are significant. We'll do another one like that. Now, we just wrote that decimal. Actually, I'm gonna keep this thing going just to prove a point. These are all ending zeros, and we've got a trailing decimal somewhere in the mix. All of those are significant. 3 is significant, 2 is significant, 8 is significant. That's not duh. Here's the funky part. This is significant, this is significant, this is significant, because they are ending zeros and there is a trailing decimal involved. This tool, even though it's a really big thing it's measuring, could measure down to this place value. This is a real precise tool with a really specific thing that it's measuring. Okay, so this one number has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That number has 10 sig figs. Because all of those zeros are ending zeros and there's trailing decimal, those are all significant. Give you some examples that are not significant. That's an ending 0 right there, but there's no trailing decimal. That is not significant. It says a big number. This is 4,810. Without that 0, it would be 481. You need the 0 to show how big it is. But like your ball of yarn, you don't really know exactly what that amount is. That tool can't measure there. So this number only has 3 sig figs. Which what that kind of means in the real world. The tool that made this measurement was sure about the 4,000, the 800, and the 10, but then it didn't really know the other stuff. I'm going to switch pages again. I'm going to pull this page. Actually, I'm going to pull this page. This is the first page I was on today. With your ball of yarn and your fancy measuring tool. Your fancy measuring tool could see down to that little tiny place value. Your ball of yarn while it was measuring the same thing, the tool itself was not precise enough to see any of these smaller place values. It's a little funky to wrap your brain around. These are trailing decimals with no decimal, trailing zeros, ending zeros with no trailing decimal, which means we know it's the magnitude of 200, like that's how big it is, but this tool can't see exactly how precise, like it's just a less precise tool, so it's going to give you this kind of number. Similarly, this tool could see to the tens place, but it couldn't see beyond that. And beyond that, we really don't know. So just to take that another step here also, this number is a big number, sure. This might be like gallons of water in one of those zoo fish tanks or whatever. Like, it's a big number. But, like, if we added another gallon, could we really tell? No. Like, you pour a gallon of water into a zoo fish tank, or, the seal, think of like a really, 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 really big bathtub, into a lake. You pour a gallon of water into a lake. Does anybody notice? No. Unless you have the kind of tool that, like, can pick up on it, then you notice. But if you've got a tool that can't see that small change in this really big thing that you're looking at, then you know it's a big number, but you don't know, you can't have, this tool is more precise, this tool is less precise. I'm going to link you a TED Talk also about landing on, I don't remember, Mars or the moon. Either the moon or Mars. And that will get you another, like, level of, like, understanding of this stuff. Just in terms of how precise your tool is can have a huge impact on what you can actually do. Okay, but for this moment, since there's no decimal printed here, we know this is a big number, but the only thing that this tool was picking up on was stuff of this magnitude. There are only 3 sig figs in this number. Okay. This is a video, you can fast forward and rewind. I'm going to pull on my screen the PDF that I'm going to share with you, and we're just going to do a few examples from here, and you're going to do the rest of the page. So let's do the first 3, and significant figures practice, Sig Fig. This is a day that you could do this page on the computer, and that would be fine. Your computer is fully able to handle this set of questions. I'm gonna write it because I would keep all this stuff in my notebook, and you are invited to do whatever floats your boat. I think keeping it in your notebook is gonna be helpful, but I'm not gonna make you do that. Okay, so the question is, how many significant figures do each of these numbers have? This one has 1, 2, 3, 4. This one has 4 sig figs. When you're doing these, you do not have to write the word sig fig. I'm going to show what I'm doing. There we go. So this is just the practice page. I'm going to link you also. That first number has 4 significant figures. And they're all like normal numbers, not zeros. Yay. Number 2, now you're into the zeros. Okay, so that's what's printed on the page, and it wants to know how many sig figs. There's the zeros. Okay, these are beginning zeros. They are not middle zeros. They are not ending zeros. These are beginning zeros. Beginning zeros are never significant. They show this as a small number, but they don't add to your level of confidence of the actual measurement. These beginning zeros are not significant. In this number there are 1, 2 sig figs. I'm going to do 1, 2, and 3 with you, and you're going to do the rest of them. The next one is 890. You will note, because you're already astutely aware of this kind of stuff, they did not print a decimal. No decimal in this picture. If they had, it would be a totally different measurement. Even though in math class you would say they're the same number. Here we're looking at measurements and amount of confidence in your measurement. There's no decimal. Therefore, this ending 0, it's at the end of the number, is an ending 0. Since there's no decimal, we're not confident. The tool knows that it's 890 something, but it can't see precisely enough to pick up on the ones place. So we have 1, 2 sig figs, and that 0 is not a significant figure. So you are going to take the rest of this PDF and try the other 20. You're going to try 17 of these on your own. Oh my gosh. Actually, looking at the end of this, we're going to do at least number 19 together. And I'm going to do number 8 with you as well. Okay, so number 8 says, then you just have to do 15 on your own. 8 says 3.4 times 10 to the 4th power. And every year I get folks saying, like, what do I even do with this? And here's where we're gonna go right now, right here today. Don't worry about it. Just don't worry about it. Pretend like it, I mean, you know it's there. You know you've got a times 10 to like a power. Oh my gosh. Within the next 2 weeks, you're going to figure out how to conquer that. And for this particular moment today, here's what you're going to do instead. You're going to completely ignore it as if it's not even there. Because this times 10 to the whatever shows you the magnitude of the number. It does not add to your confidence. Just the same way that this 0 shows you that this is 890 instead of 89 or 8,000 or whatever. Like, it shows you how big it is. Some zeros show magnitude, how big or how small. Other zeros show confidence. This 0 shows magnitude. These zeros show magnitude. This thing shows magnitude. None of these, in this particular case, show confidence at all. This times 10 to the 4 means it's a big number. The things we could actually measure, 3.4, there's only 2 sig figs in that picture. If you're like, what even just happened? Just in your mind, just imagine or ignore or delete the times 10 to the whatever. Soon you'll be very confident with it, but if you're just not right now, that's totally fine. Let's do number 19 as well, even though, because I said I would, even though by now I'm gonna even bet that by the time I write this, you might have like scrolled there and been like, I got that. So here's another one with a times 10 to the something. Here the times 10 is to the negative 10. You're like, oh my gosh, now we've got negatives. Fine. That just means it's small. I'm not even going to put the question mark exclamation point, because you already know that in the worst case scenario, you're going to just completely ignore it. And if you're another step into your processing, this shows magnitude. If you're another step into your processing, you might notice that times 10 to a positive number is big and times 10 to a negative number is small, but that is for a different video. Right here we have 1, 2, 3, 4. We have 4 sig figs. I'm going to end it there and let you try some of this on your own. Let me know your questions and see you soon.